Hello everyone, welcome back. So in the previous video we have installed LM Studio and got the Google's Gamma up and running. But if your model is generating text character by character, your hardware settings are holding you back. So today we are diving into GPU offloading, speed strategies, guardrails, and exactly what happens inside your system when a model loads. So let's get started. The first thing would be fitting the entire model inside your GPU's VRAM. If a model spills over into a regular system RAM, your performance takes a massive hit. And that brings us to the very first hardware speed strategy, picking up the right quantization. So you can go to this. This is the fourth option where you can look for the different models available. You can search for the models. The very first thing which appears over here is Gamma 4 12B, which is 12 billions parameters, and it is QAT, means quantized aware training. So even if you read the description over here, you will get to know it aims to keep quality close to bfloat 16 while using much less memory to load the model. So in the previous video also I have talked little bit about the quantization. It compresses the model weights, okay, while a 16-bit uncompressed model may sound crisp, but the ultimate sweet spot for a local AI is a QAT model. So it retains almost the model intelligence while slashing the file size almost into half. That reduction is often the exact difference between 100% on your GPU versus dragging through CPU RAM. So like in my previous video, I have already downloaded Gamma 412B QAT. So let me do one thing. Let me quickly click on it, and you can see the model is getting loaded. I can go to Task Manager, and then we can run to this. Sorry. So you can see the memory is almost 13 GB in consumption, and if you see the GPU, I have a 2 GPU in my system installed, GPU 0 which is 12 GB and GPU 1 which is 8 GB. So since this particular the model is almost 7 GB, so it can fit almost in my single GPU. You can see it over here. So this is what we have to do is, we have to always try that pick the model which fits a single memory slot. So suppose if you have a GPU which is having a VRAM of 8 GB, try to means download a memory or have a the model which takes that much of memory. Now we are moving on to our second strategy, which is GPU offloading. So if you click on this model load settings, which is the gear icon present over here, so you will see first of all the first thing is the model supports up to this many tokens. We will talk about the context length later. The second strategy what we're talking about is GPU offload. So generally what happens is the neural networks are split into the computational layers. So if you have an 8B model with 32 layers, LM Studio decides help you to decide that how much layers get assigned to your graphic cards. So here this particular model, the LM Studio is offering me to have maximum, which is the 48 layers to be offloaded to your VRAM. Okay, so it totally depends. So since my first vCPU, I have already shown you that it is 12 GB, I think I can offload all of the layers. So particularly if you don't have that much space available, what you can do is you can little bit slide it down and you can have 32 layers also loaded. So it's completely fine. So if you leave this at the 0, so what will happen if suppose I leave it to 0? So your CPU does all the heavy lifting, and you will get around 2 to 4 tokens per second. But if you slide the the GPU offloading settings to all the way to the max, offloading 100% of the layers, your GPU takes over entirely. Suddenly you are now flying at 40, 50, or even 60 tokens per second. So at the moment I am keeping it at max, which is 48. Okay, now the thing is, there is few more thing. Like the third thing what I want to talk is about flash attention. So we have to keep the flash attention on. So means flash attention optimizes how your GPUs calculates memory math during the long chats. It slashes VRAM consumptions and speeds up generation time, especially when dealing with the larger prompts. Now we have something called evaluation batch size. Yeah, so here if you see, the fourth thing is evaluation batch size. Here by default it is 2048. So sometime when like you are dealing with a huge chunk of text, so I think it should be like it should not be much more or it should not be much less also. For example, increasing this from default to 5112 or 1024 allows your GPU to process your initial prompt much faster in parallel, eliminating that 10 seconds pause you get when you type something in the model and the model starts replying. So mine is by default 2048, and it totally depends on the kind of the system also, what's the build up you have for your system. Now we are talking about the last thing in this thing, this model settings, which is crucial, is the context length. Now since you see that model supports are up to 262144 tokens, but you can see here it's already settings is 8192 for mine. So it's definitely not required that you have to move it to to the max, because you needed a max max tokens only when you are dealing with a huge file. But since if you are talking, if you are doing some a normal chat, if you don't have to read a complete your code repository, you need not to be keep it so much high. So the reason is why you need to keep it means like almost around 4000 or 8000 tokens is like if you move up the context length to suppose 32k or 64k, what happens is it consumes the VRAM. Actually it consumes the VRAM because the LM Studio or whatever the the runtime we are having at the backend, they don't want to break the things. They want to remember the whole context. And where does this whole context resides? So it resides into something called KV cache. Okay, and it resides into cache is a concept, and it resides into your VRAM. And if you move it up to 32k context, so what will happen, suppose you have an 8B model which can quietly consume an extra 4 to 6 GB of the VRAM. Even you have not started talking, you are not getting any reply yet, but still it will reserve that much of space into into your VRAM. So I will only recommend when you are summarizing a massive PDF or analyzing a full code repository, then only we need to set the VRAM to like 32k or 64k. But if you are doing a daily chat, it's better to keep it around 4000 or something, around 8000 tokens for daily chats. So since mine is almost settings where you can see that is almost done, and once you are done with the settings, you have to click on reload to apply changes. So you will see that the model is reloading now. So these were the few things which the section 1 of this video we were discussing. We were talking about the hardware strategies to run your local LLM faster. Now let's move to the second section. So in the second section we are talking more about what happens under the hood when a model loads. Okay, so now we have done our speed settings in the section 1. It's better to it's good to know what happens at the the back of the LM Studio. So this will help you to troubleshoot instant crashes, freezing, or random slowdowns before they ruin your workflow. And it is always good to know what's going in the backend. So first of all, let me click on this app setting and let me take you to this hardware section. So if you see here I have a RAM and VRAM, and total RAM I have is around 32 GB, and VRAM is which is your graphic cards, which is 20 GB. So here, since my model is already loaded, so here in the resource monitor you can see RAM plus VRAM is 6.97 GB is totally consumed. Okay, and in CPU currently I'm not doing any kind of processing, so CPU is not showing any spikes. Okay, you can also see this resource here also. It is also showing up here. So there is some settings where you can turn on and you can have this. You can see it over here in the settings only, or not. You can always come to this. You can click on this gear icon over here, and you can always come and you can see the resource monitor over here. So now the thing is, once you have loaded your model, and since my model is not it's just around 7 GB, so you can see the model is totally allocated to single GPU over here. So what happens if a model is is of larger size? So generally they have a spillover effect. So what will happen is, since I have like 2 GPU with me, the model will spill uh, to uh, uh, to the leftover content. Suppose this is 12 GB and this is 8 GB, and it's better let me eject this model and let me choose the another model, which is Quen. So this is, you can see it's 16.28 GB. So what I will do is I will quickly click on this. While it is loading, I go to task manager and let me go to this performances. Oops. And you see over here, so the first GPU has 12 GB in total, but 9.3 GB is consumed, and also to the second, which is 8 GB total, but 6.9 GB is consumed. So you see the spillover is taking over place over here. Suppose you don't have enough GPU with you, so what will happen? So the spillover will take from a place in between VRAM plus your system RAM. And suppose you don't have enough your system RAM also, so finally the load will come to your CPU. Okay, if you don't want to do the GPU offloading, what we talked into our first section, so most of the task or sharing will happen between your memory and your CPU. So what happens generally is, so if all the things are into VRAM, so you get an average generation speed of 40 to 60 tokens per second. If there are hybrid, so your tokens processing or generation speed will reduce. For example, it will be 15 to 20 tokens. And suppose everything is taken care by CPU only, so your token or average generation speed that will reduce much to 2 to 4 tokens per second. And it will be much slower. So I can also, since we have loaded this, this is Quen model, and let me have a new chat. So here, hello, help me know about you. So you can see here, so it's taking a little bit of more time compared to what means gamma model was taking. Gamma model was much faster because our first rule, it is completely means loaded into one single memory slot because it is smaller, and since Quen is much bigger, now it has been split into two of my VRAM. So you can see here, it's doing the computation, but it is slow. And meanwhile, I have I went into a different chat window where I have already done it. So you can see here 32.83 token per second the speed was, and it took 1.05 and processed 550 token. So you can always see a model for a gamma, but if you see for the Quen, so generally it takes more time for me or Quen to load. So, and rest, talking about the backend, another thing would be if I go to the task manager, and if you learn about the LM Studio much, so you can always see, like suppose I stopped or unloaded my suppose I eject my this model. So as soon as I eject it, you can see the drop in the memory. See, so as soon as you eject it, so at the backend, the llama.cpp or LMS, whatever the server we have running, that instantly gets terminated, and the memory gets free. You can see over here the memory instantly got free. So this helps you to better understand how the LM Studio is managing the memory, how the memory is being utilized efficiently. And one last thing I wish to add is, so here if you have a multiple GPUs, so we get in strategy. So like one is split evenly, the other is priority order, and the third is tensor parallelism. For me, I have done is like I have chosen is priority order because most of the time like I use a smaller model like for gamma only. The reason is that I most of the time I do most of the means the coding, or we are taking a simple chat. So you don't need to always load a bigger model and always try the things out. It's sometime if you are doing a simple chat, or it doesn't require much much regressive task, so you can always load a smaller model. So I have used priority order. Split evenly, the reason was not using of split evenly was it was and for any of the like when what it was happening, the performance was not getting so much good. And tensor parallelism, I have not tried this out yet, but for me priority order at this point is working perfectly fine. So that's all the second section uh, regarding how the LM Studio manages the memory. We have talked about how the the memory spikes when we load the model and unload the model. So now we will move to our third section and see you there. We have optimized our hardware for speed, looked at how memory gets allocated. Now let me ask you this: what happens when your chat gets way too long, or when a model starts repeating itself in an infinite loop? So, and this is very, very common. This happens. That's where guardrails comes in. Guardrails are the safety boundary and system rules that keeps your local model running in a stable and structured way. So let me select one of the model. The first guardrail we will be talking about is a critical one, is your context overflow policy. So let me go to, if you see over here, context overflow. So here the, the every model has a hard limit on how many token it can remember at once. If you remember, we were talking about the context overflow, and we were suggesting you to, keep it 4000 or 8000 token limit if you are having a normal or daily chat. So what happens, like if the, the conversation, you started a conversation and it happens to, it increases like more than 4000 or 8000 tokens. So if we don't set this context overflow policy, generally what will happen is like either your model will throw an error or your session will crash. So here in LM Studio, we get three policies to prevent this. So the first one is the rolling window. It is also called truncate oldest. So this automatically drops the oldest message in your chat while keeping your system prompt intact. Your chat continues seamlessly forever without hitting a memory wall. And the second is the truncate middle. So what will it does, it preserves the original instruction and your most recent message, and it will drop the middle conversation history what you have is. And you can see currently it is my setting is by default is at truncate middle. The third is stop at limit. This act as a strict guardrail, stopping generation so you don't lose track of your original context during sensitive tasks like coding. So if you are doing some, something coding and you want to preserve all of your data, you don't want to truncate the oldest message, you don't want to truncate the, the middle conversational history. So it's definitely to have something called stop at limit. And also generally when you read a repository, when you have a code, you generally try to keep the context length at max or 32k, or if the model supports 64k, that also works perfectly fine. And if you have enough sufficient memory for, for your VRAM memory is available, so that's a best thing what you can have is. Now the second thing what I wanted to talk about is system prompt. So generally the system prompt is like you can set for example, here you can see only answers in rhyme. For example, you are a coder, you are a Python, means you write in Python code. So you can set here something like you are a Python expert, and something like respond only, sorry. So even like see, I wrote only in capital, so it's understand that tone also, like if something is written in caps or in bold, it means it is must to have. So with valid JSON formatting, something like this, you can always set. So what will happen is like system prompt is your top level, you can think of a command guardrail. It sits above the user prompt to dictate behavior. You can enforce the tone or restrict the output formats like I am doing over here, like forcing the model to reply only in structured JSON or a markdown language. However, for a system prompt to actually work, the prompt template must match your model's architecture. If you load Gamma using Llama 3 and chat ML template, the guardrails break, the model get confused, and confused spills special token into the chat, or it may output something like which is not worth. So but LM Studio usually auto detect this, and it's always good to check like format matches your loaded model family. So your system means whatever the prompt template should always match the model family. Now the fourth thing what I think is about the sampling. Okay, we have a something called temperature guardrail. So temperature guardrail is something suppose it's like you can think of it as like if you set it like too high, the model will go wild and it may hallucinate. It is more like it will give you, it becomes more too high, then it becomes wild. Generally it's better to keep the temperature at zero point 0.8 if you want something 0.7 to 8 if you want something creative writing you are doing. And if you are coding, and if you want to stick to something very, if you want a strict things like you're doing maths, you are doing factual question and answers, so it's better to keep between 0 to 0.2. Okay, and the last thing over here is important thing is repeat penalty. So if you ever seen your model getting stuck into a loop repeating the exact same sentences 50 times, so setting a repeat penalty around, which is here it is set to 1, but generally we set to 1.1 or 1.15. It acts as a guardrail that penalizes token reuse, and it's instantly kills the looping behavior. So you will not find that you are getting the same answers again and again. So there is much more. You can see here we have a structured output also, like what's the structure you want to have in an output. And there is much more. There is CPU threads, what would be the stop string, suppose you want to stop. So rather than truncating, you are stopping the button or ejecting a model, you can have some string over here. You can create some string and press enter, so model will instantly means that will act as a stop string for the model. So here we have much more things to learn. I will explore it and keep learning. So, and also if you come across something which I have missed in this video, please share with me, or always find free to chat or comment below to in the video. As a conclusion, by combining the smart hardware offloading, understanding memory spills over, enforcing solid guardrails, you can have complete control over your local AI setup. If you found this power user strategies helpful, smash that like button, drop your favorite local model down in the comment. I will see you in the next video. Bye bye. Thank you.